Thank you everybody for joining this webinar. Today we are going to talk about the Parlé Beamtracking microphones. And my name is Mauro Barbieri. I'm field sales engineer at Biamp, and today I'm with Giulio.
Welcome everybody, also from me, Giulio Ferrari, applications engineer, and we're here in the Biamp offices in Italy for the webinar of today. And from the UK, we have a special guest, our colleague, Jason Spooner. Jason, can you hear us?
I can hear you just fine.
Very good, very good. Jason will explain at the end of this webinar how to optimize the microphone. But before starting the webinar, just a few notes. If you have questions, please type in the question box. At the end of the webinar, we will have a Q&A session. And after the webinar, you will receive a link where you can find the slides and the recording. Then let's start with just an overview about the Parlé microphones. So, of course, the microphones are one piece of the puzzle in the conferencing system. We're talking about conferencing microphones, together with loudspeakers, camera. But I like to think that the microphone is very important because it's the key to be understood from the other side of the video. So it's a very important piece of the equipment of the conference room. And talking about the Biamp conferencing microphone, all the Biamp technology are there. So starting from the echo cancellation, the noise reduction, the beam tracking, and the Parlé microphones are part of the workflow, starting from the designer tools, where we can put all the details about our projects and get the design, up to the launch, that is the Biamp way to automatically tune the room. So this is the entire workflow built around this beautiful piece of technology. And I introduced you the beam tracking technology. I want to explain how it works. And for explaining how it works, I need to start from conventional microphone. So the classic microphone has a 3D space where the participants are and where the microphone can pick up the voice. So this is a predefined area where the participants should be. And when we have to equip the room for multiple participants, we have to add more microphones, more zones, more areas where the microphone pick up the voice. And this is one way to create a conferencing system. We also have newest technology that is using multiple capsules and creating a bigger area, and with the DSP and some special processing, we can define the zones, so virtual zones where this microphones group can pick up the voice. And this technique is called beamforming. But still, as we have with conventional microphone, we have the problem that the area for the microphone pickup is predefined. So if someone just goes outside that area, the microphone is not able to pick up the voice. So this is the challenge. And the beam tracking from Biamp is solving that challenge, because it's a kind of dynamic beamforming, so able to move this 3D area, this microphone pattern in the direction of the participant. And the participant could be anywhere, moving as in this slide, and the microphone it's responsibility of the microphone to change to move the beam in the direction of the participant. And this has two major advantages. One is that in this way, there's no predefined position for the participant. The second is that we direct the beam to the participant, and also we ignore all the sounds outside the beam. So it's a very, very clever way, and is a specific technology from Biamp. Going to the catalog of the Parlé microphones, we start from the table microphone. That is exactly what we are using now. It is in front of us. TTM stands for Tazira table microphone, and is available in white and black, as 4 touch buttons for enabling the mute feature, and as an LID all around the microphone, showing when the microphone is working or when it's muting. Also, there is an accessory if we want to fix the microphone in the table. Usually it's free to move in the table. We can position the microphone close to the participant, and but in that case we have the cable on the table. If we prefer to fix the microphone on the table, there is this optional accessory, and in that way the cable just drop down to the table, and it's easier, and we have a very clean environment. The next entry in the catalog is the ceiling microphone. The same as the table microphone, is very small in size, very thin, and very elegant, available in white and black, and is designed to be as discreet as possible, and very appreciated by the architects and the designer, as the same LID all around, and so we can easily understand if the microphone is open or closed. Even in this case, we have an accessory to make it even smoother, let's say, because it's installed under the ceiling, and the thickness is just 15 millimeters. But if we want to hide the microphone in the ceiling, we can do with the optional accessory, the flash mount optional accessory, is this tool, very easy to install, like using the same system that we have for our ceiling loudspeakers. In this way, we can flash mount the microphone in the ceiling, and what we get is the 2 options. One completely integrated in the ceiling, like you can see in this slide. In that way, the LED is visible in a range of 130 degrees, or we can have a slightly less recessed installation. In that way, the LED is visible from 170 degrees. So we have this flexibility to have completely outside the ceiling, partially in the ceiling, or completely in the ceiling. So with this optional accessory. The third entry in the catalog is the pendant. So every time we have a very high ceiling or an open ceiling industrial look, and there's no way to install the ceiling microphone, we can install this pendant microphone, very elegant, very small. In this case, we have 3 LED, so we are able to see if the microphone is open or closed from every direction. And we have more flexibility for the distance that we can, and the position for the installation of the microphone. Thanks to the cable, we can arrange the length of the cable that we need for that installation. About the codes, starting with the ceiling microphone, the TCM stands for Tazira ceiling microphone. X, this is the ceiling microphone, and we have it's composed mainly from a network box and the microphone itself. But we have another option where the network box includes an amplifier, a PoE amplifier, and this simplifies a lot the installation because the amplifier is installed over the ceiling, and from there we can start the connection to the loudspeaker. So we go up to the ceiling just with one cable. Everything is in the network box. The connection to the microphone and the amplifier for the loudspeaker. And this is the TCM-XA, where A stands for amplifier. Then we have the TCM-XEX, because every network box supports two microphones. The first microphone comes with the SKU of the base option, the TCM-X or XA. But we can connect a second microphone. In this case is an extension, and the name is TCM-XEX, the extension ceiling microphone. More or less the same arrangement for the pendant. We have the TCM1, that is the base SKU, where we have the network box and the microphone. 1A as the embedded amplifier, same reason, to put everything on the ceiling and simplify the installation. And the 1EX is the extension. But in this case, we can have two extension from the first network box. So we can have the network box with the base microphone and then the first and the second extension. So up to 3 microphones for one single connection from the processor. The last one is the TTM-X, that stands for Tezira table microphone. And in this case, we don't have the version with the amplifier inside because, of course, the network box is not in the ceiling, but is usually under the table. And the XEX is the extension, even in this case, the base network box supports the installation of 2 microphones. So we have a different range of microphone depending on the size of the room and depending on the aesthetics that we want to receive. But it's very important to understand that we have all the flexibility, and with this system we can keep from the tiny other room up to the large room because it's a flexible and scalable system. So when we want to hide all the cables and we want a clean as possible installation, we can opt for the ceiling microphone. In that case, all the cables and the electronics are in the plenum. One cable is enough for going up from the processor. We use just a category cable, so we simplify the installation, and that is very, very fast. When we don't have the ceiling or the ceiling is too high, we can opt for the pendant microphone. And in other case, we also have the option of the table when the table is the main focus of the meeting room, especially in small other room, for example. But this is just, let's say, a way to select the right microphone based on aesthetics, on visible requirements, and on the physical aspect of the meeting room. But for the choice of the right microphone, we need to take in account also the room acoustic. And I'm going to explain the reason, because mainly in every room we have the typical noise floor and the reverb time. And as much the noise floor and the reverb time are high, as more challenges is the environment, and we need to consider this for the choice of the right microphone. Just the most important value that we need to evaluate is the signal to noise ratio. So in this picture, we have the participant of the meeting, and on the other end, we have the microphone that is listening the participant. This black signal is the background noise that is part of the signal captured by the microphone. And this is the signal, the voice coming from the participant that decrease 6 dB every time we double the distance with this inverse square law. So for example, in this case, if this is a loud talker and talk with a 65 dB pressure at 1 meter, at 2 meter, that value would be 59, for example. And this, as you can see in the slide, is the size, the level of the signal. This is the level of the noise, and this is the difference between the signal and the noise, the signal-to-noise ratio. And this is very important because is the, let's say, the amount of room that the microphone has to pick up the voice and not the background noise. If the background noise and the voice has the same level, of course, the microphone is not able to pick up the voice, but will pick up everything. And of course, intelligibility on the remote end won't be very good, won't be enough. So the key value is this difference between the signal and the noise floor. In the example I started before with 59 dB, so 65, for example, 1 meter, 59 at 2 meters, and a noise level of 40 dB, the difference is 19 dB. That is the signal-to-noise ratio. And ideally, we should be around 20 dB for having a good intelligibility and make the microphone able to work in the proper way. Whenever we are below 15, probably the performance of the microphone won't be enough. And this is, let's say, a very, very important value to understand and evaluate when we are going to select the right microphone. In this table, you see that we divided the performance of the room, the acoustic of the room, in 5 different levels, from poor to perfect, and which we understand the quality of the room mainly from 2 parameters. One is the noise floor, and the second is the reverb time. For example, when we have more than 50 dB in noise floor, of course, the signal-to-noise ratio won't be very good, and so we have a poor room. A good room for conferencing usually has a noise floor that is in the middle between 35 and 43. Let's see, around 40 dB, with around or less than half a second reverb time. And as you can see in the second half of this table, the pickup distance, the maximum pickup distance, depends on this classification. For example, the ceiling microphone, the TCM-X, the maximum pickup distance from the microphone to the participant, so this diagonal from the microphone to the participant, in case of a good room, is 3 meters. So you can easily understand that one microphone is enough for covering quite a big table. But if the quality of the room drops to poor, these 3 meters become 1.8. And the distance is even less in case of pendant. And so we need to use the advantage of the pendant. And the advantage of the pendant is, thanks to the cable, we can go down and go closer to the participant. In that way, we can reduce the distance and get a very good result. And the last is the table microphone. That in that case, using the table microphone, we are able to reduce the distance between the microphone and the participant even further. Like in this case, I'm less than 40 centimeters from the microphone. So depending on the challenging acoustics, so the right choice of the microphone is based on aesthetics, of course, the shape of the room, ceiling, not ceiling, the height of the ceiling, but keep in mind that the acoustic of the room is very, very important to understand if we can use the ceiling, we need to get closer with the pendant, or we need to use a table microphone to reduce the distance between the talker and the microphone to have a better signal-to-noise ratio. But one very important thing is that you don't need to remember this table. You don't need to do any manual calculation, because Biamp offers free and automatic calculators for understanding and simulating our room and taking the right choice for the microphone. And I switch to Giulio so he can explain us how to use the calculators for helping us in choosing the right technology.
Yes, thank you, Mauro. And typically the first step when we want to create a room and equip it with microphones and other AV gear is the design phase. And these acoustic measurements are important in this phase because as we saw, we can get measurement, we can decide which microphone is best to use in a certain space. And we can see the range of those microphones, and we can do the calculation and see where to place the microphone, how many of them we need, and so on. But as Mauro was saying, we don't have to do it all by hand, as Biamp is offering a few tools, all free tools, that are all available in Cornerstone, which is Biamp's knowledge base for all our products. And if we go to support.biamp.com, we can enter the design tool section where we have a lot of different designers, calculators and tools that can help us with different AV needs. And in our case, we start by seeing the Parlé Ceiling Microphone Calculator. So I'll just open this one. And here I have a powerful tool, that I can use to check in a certain room, in a certain space, how many microphones I need to install and where they should be installed. I can switch to meters. I can decide here, talking about the ceiling mics, if I want to use the TCM-X, so the ceiling mics, or the TCM-1s, which are the pendant mics. I start with the ceiling mic and I set the height of my ceiling, 3 meters. And an image here on the right is already showing me the pickup range, the diameter of effectiveness for my mic. I have the 3 meters high of my ceiling, and I have 4.8 meter diameter for the TCM-X now. Of course, since we said that the distance to the mic is one of the most important values, I can decide if I want to design the room for standing participants or sitting participant in case it's a meeting room with a conferencing table. And here we have the 5 levels that we were just describing a minute ago. And from poor to perfect, those acoustic measurements of the reverb time and the noise floor are used here to decide which is the level of acoustic that we have in a specific space, in a specific room. Again, we don't need to remember these. There's a link here that is showing us that table that Mauro was showing before. So we have the 5 levels. We can check the noise floor and the reverb time, and so we can calculate or estimate at least which level the room that we are designing will have. Then we can insert in the system the length and width of the room. So it's, in our case, I'll put as an example 6 by 4, which is in feet, more or less 20 by 13, 14 feet. And we can see that now there's one mic placed in this space. We have all the measurement of the positioning of the mic with the distance from the walls. But suppose that the room acoustic, instead of good, it's fair. So one level below that as measured. And we can measure that with a professional mic, or even with a portable device like a smartphone. We can get good results, good enough results to estimate the acoustic of a room. In this case, there are 4 mics. So I can we can really see that the room acoustics makes a lot of difference. Then we can also customize even more, because maybe we want to have a better coverage of the whole room, so we can choose to have more coverage, or vice versa, we can have less coverage. Maybe we don't need to cover the full room, maybe just a part of it. So we can play with these settings, and also we can generate a link from here. So we can go back to this page and edit it at any time. So change, maybe we have new information about the acoustics of the room, we can go back and edit our results. I will reset the form and try with the TCM, so the pendant mic. Again, you see that now the form is changing from ceiling height to microphone height. This is because this is the height of the microphone relative to the floor, and being a pendant mic, we can, for example, adjust it and lower to be closer to the participants. We see that, for example, again, I'm using a good room acoustics, same measurements as before. We see 4 mics have been placed by the system automatically. But we exploit one of the biggest advantages of the pendant mics, the fact that we can lower the mic to be closer to the participants. Again, the distance is everything. So if I put 2.4, we really lower the mic to be closer, then we only need 2 mics for this installation. So we can really custom tune the system and the form here to get the best result for this room. And again, we can play with the coverage, more or less coverage in the room. Maybe we only need to cover a certain spot within the room. Another tool is similar, but it's regarding the tabletop mics. Again, I will set 2 meters, and it starts by asking the room measurement. So again, same room, 6 by 4, and I'll place a table in the middle of the room, 2.5 by 1.5 meters. So it's a medium small room with space for 8 people around the table. And again, the system is already placing 1 mic, and we can see also with this type of view the coverage circle, the diameter that it's covered by that mic. What if the room acoustic is fair? Then we will need 2 mics placed on the table. So it's really in few seconds we can have our design ready for a specific room. Again, from here I can generate a link to be able to edit the project at a later time. Going back to the list of design tools, the first 3 are called designers. It's warehouse designer, classroom, and conference room designer. Let me open the conference room one. This is a very powerful tool that it's taking the power of the mic calculators, but including more AV equipment as well. So just quickly entering the room measurements, I can also decide if I have ceiling tiles, place my table, or very quick. And from here, I can interactively choose if I want to place ceiling, pendant, or tabletop mics. And then I have a few different options depending on my choice. I could also use a video bar like the VBC 2500 or an audio bar. So from here, let's put the tabletop mics, for example. From here, I have a very powerful tool to be able to create the whole design for my room. Acoustic, we'll leave it to good. Select the DSP family, Devio or Tesira, based on the needs for this room. And just like that, I have a full design for my meeting room. In this case, there's 1 mic at the center of the table and 2 speakers already placed in the right spots. And from here, I can create the whole bill of materials. So not only the mics, but the speakers, the sono in this case, everything that I need. Most solutions are included in bundles, including even the camera if I specify one. So very easy way to design an audio and video system for a meeting room. What about the deployment? When I have the bill of material and I want to go ahead with the deployment. Well, let's see. I have a couple of microphones here as an example. One is the one that we are already using for the webinar, is the TTM-X, the table-to-tabletop mic. As we said before, black or white versions, very thin, rubber band to be placed on the table, touch buttons to mute and unmute, and a very simple RJ connector to connect it to the network, the mic box. This is something that typically installs under the table, and it can support up to 2 mics, just like that. The third port here is, again, RJ connection, and this goes to the DSP with a simple category cable to the Tezera or Devio. Same concept for the ceiling mic. I have the white version here, again, very sleek design. We've seen the different mounting options with flush mounts, but you can also just put it through the ceiling and screw it with this system. And very beautiful solution, RJ connector on the part here that it allows for a very simple connection to the rest of the system. This comes with a mic box. This is the TCM-XA, so is the version that supports 2 microphones here, and also 2 PoE ports for speakers for 2 channels. There's also the version without the PoE amp outputs, just the two mics. This installs on the ceiling, in the ceiling, and it allows with this port a very simple connection, just 1 cable going from the DSP, the Tezera or the Devio, to the ceiling with a simple cat cable connecting to this. And then from here, from 1 box, I can run the 2 mics and 2 channel of speakers, so up to 4 the sono speakers here. So very, very simple. So from here, direct connection to the sono speakers that I have here on my back, and to the DSPs, the Tezera Forte, for example. So yes, supported family of products, Devio and Tezera, both the rack mount Tezera and the Tezera Forte and the Devio SCX family are supported. And here is a simple diagram on how to connect a tabletop microphone. So the tabletop box, up to 2 mics connected here, and then 1 cat cable to the Tezera system. Another cat cable is going to the ceiling when we have, in this case, we have the amplifier, PoE amplifier, that supports and gives power to the sono speakers. Very simple solution. Even more simple is a solution where we have the ceiling mics. As we saw, just 1 box does it all. So from the DSP, from the Tezera, we run a single cat cable through the ceiling that connects to the TCM-XA in this case. So it's the mic box that does work as an amplifier for the speakers as well. So 2 ceiling mics can connect to the 2 ports, and 2 audio channels for the speakers, so up to 4 the sono speakers daisy chain. So really simple to deploy. So simple design. We have the calculators, we have the designers. Really, you can design a whole room within minutes. simple deployments, it's really quick. No need to run tens of cables, just a single cable to the ceiling, and the box does it all. Very simple connection. What about configuration? Well, configuration of the system is, again, a very simple task. It's a matter of just pressing a button, the launch button on the Devio or the Tezera products. When you press the launch button, the Devio or the Tezera, first of all, check which devices are connected and the upgrade the firmware if needed with the single devices that are connected. And then there's a whole procedure of measuring the acoustics of the room. Sound is produced and the reverberation is measured, the frequencies are measured. So it's a quick procedure of just a couple of minutes, depending on how many devices are connected. But with this measurement and comparing this measurement to target values, the system is able to configure itself and to tune it for the optimal performance, just like that. The same concept is inside the bar, the conferencing bar, the ABC and the VBC 2500. Nice thing is that at the end of the launch, we can also download a report card with all the measurements before tuning the room with the automatic configuration and after, and this is something that we can show our customers and to show them what has been achieved in that particular room. So really quick solution from the design to the deployment to the configuration, which can happen in a totally automatic way. But there's more. If you want to delve a bit more into the configuration to really achieve the best in your system, there are other options. And I
switch to Jason. Now.
Yes. So he can guide us through a couple of nice options here on how to best configure the Parlé system for our needs.
Okay, Jason, now you are the presenter.
Thank you. And the webcam. Nice to see you over there in Italy. So I'll just introduce myself quickly. I'm an applications engineer here at Biamp UK. So spending most of my time assisting customers with their Tezera systems and deploying them so that we get the best sound. Bear with us for a moment while we wait for GoToWebinar to switch over to my view. It's been a bit laggy today. I'm just waiting for it to switch to my screen. So Giulio spoke about Biamp launch, and obviously it's a one-button configuration. And I'm going to show you how we can scale things quite simply within Tezera. The beauty of the Tezera platform is all we do is assign blocks to hardware, and it's the same for the Parlé mics. I'm going to show you something very simple to begin with, and hopefully you're seeing the Tezera software at the moment. I believe so.
Yes, we can start.
Great. So I've got a very simple little system here, and you can see it if you're looking at the webcam. You can see on the table I've got a couple of microphones, some ceiling mics, a Forte X, and the various Plenum boxes. And I've pre-organized the files for the bits that we're not as interested in, the USB, so the far end coming into the room, and our USB transmit, which is where we're going to send our microphones. And starting at the beginning is always the best place. We'll throw in a couple of Parlé microphones. So assigning blocks to hardware, I've got a TCM XA box here, so it's got the amplifier built in. And I've got two ceiling microphones connected to it. I can use the Parlé amp block, perhaps one channel for 8 watts continuous, and we'll put the block into the configuration file. So here's going to be our room output. You can just connect that up. And I'm going to build the entire signal chain first, and then we'll run through what it's doing and how to use it. So In the control blocks drop down, we have our Parlé processing. I've got two inputs here, TCMXA. We'll come back to the UC setting in a moment. There are a few to choose from, but I'll start with generic. We can choose to include the AEC processing within the block itself, which can be helpful in keeping things clean and organized. We can also use the analog input associated with that AEC if we want. I won't here because we don't need it. And then we get two blocks. Connect everything up. Connect our AEC reference. So I'm going to put that on the output. Everything that we're sending to the local loudspeakers that we want to remove from the microphone feed back to the far end will be sent to the AEC reference. And there we are. So we'll just compile this now. And it's given our list of hardware, a TCMXA with an extension mic. Now, Biamp launch, as Giulio described, will do all of this part for you. So the configuration file is pre-built and it will also detect hardware. We need to assign our blocks to hardware. So I'm going to go to the equipment table now. I get a warning there because it says it's different. It's because I've got a Forte 800. I would only need to buy a 400, but it's an 800 here on the desk. And I have a TCMXA, and it's going to be managed by my Sierra Forte X. And we'll just get this sent off to the system, and then we can start looking at. I do want to start audio. And there we are. So we've already built a working system essentially. So we can plug the USB cable in. I haven't connected a loudspeaker today, but the system is functional. So the signal path was built very quickly just by adding in a couple of blocks. And then there's a few things that we can optimize throughout. So this is the standard setup procedure. They are microphones at the end of the day, so you can build your signal chain exactly as you wish. But I'm just going to show you the predefined, easy to deploy system which gets good results quickly. And we'll start at our inputs. And as the gents were mentioning, the height above the floor defines how wide the pickup cone, the coverage is for a ceiling mic. So we can set this here. Generally, you would set that to the actual height above finished floor in meters here. But just switch over briefly to the calculator again. You'll see what effect this actually has. So decreasing the height above finished floor will increase the coverage cone, and increasing it will decrease the coverage cone. If you need to, you can manipulate that value slightly. If you want to bring the coverage cone in a little bit tighter or a little bit wider, you can manipulate that in the height above finished floor setting. Now in the mics themselves, in the X series microphones, we have the ability to turn on and off segments. So in the room here, we've got a doorway behind me. We might want to stop the microphones from tracking in that angle. And we can do that quite simply. And if I switch down here to the segments setup utility, so there's a couple of utilities here to help you configure the mics when you're doing an advanced configuration like this. Generally, if you want full room coverage and your room, it may change orientation, the table might change, get moved around, different table layouts. You want to leave them all on so that they'll track no matter where people are. And that's a dynamic thing that's happening all the time. But if you want to exclude zones, you can do it like this. And if I turn on the segment mode, if you can see my webcam at the moment, it's probably a bit smaller on the screen, but we can turn segments on and off, and you should see that with the LEDs disappearing from the front of the microphones. It may not be that easy to pick up on the cam. This is a nice utility so that when you're actually commissioning the system, enable it on the LEDs, and then you can very clearly see if I want to exclude this area behind me, you literally just turn the LEDs off in that orientation. These can also be controlled by presets if you want. So if you have different room modes that you want to account for instance, you have a presenter situation where you'd like to turn off half of the microphone so it's just focused on the presenter, you can control these in presets and just recall the preset and put it into, you know, pick up everywhere mode or track only in this orientation mode. And that's about it within the microphone to actually configure. And so we move on to the Parlé processing. So this is the default processing. We've included the AC processing inside as well. So nonlinear processing and noise reduction is set optimally, and we can come back to that in a moment. And you'll see that we have 5 acoustic settings. And there's a little link here to say, what do these settings mean? And they go back to the table that we showed you earlier in the webinar. So depending on the acoustics of the room that have been measured, will depend on one of 5 different preset areas. And if you want to simply tune the room, you can just select the one that you have. So if you've measured your room and designed your room using the calculators as a fair room, you can hit the preset and you can make a call and you can see how you think. And in fact, these are runtime parameters, so you can cycle through these while you're on the call and listen to the effect that it makes. In fact, something that I like to do when I'm using this is actually set it high. Start at great or perfect, listen on the call, and move your way down into a setting that sounds preferable. The reason I do this is because the higher up you get, the less we have to deal with the room acoustics, the room noise, that kind of thing. So the perfect setting is allowing so much more of the microphone through. And as you work your way down towards poor, we're obviously having to filter out, EQ it a bit more heavily, and so on. So use your ears, but the measurements that you took and the design that you made for the room generally dictate the preset that you'll go for first. But if we go back to good and say that this is a standard room, we can go to the custom setting and then we can have a look inside what's actually happening in the block. So we take the arrow and let's move this out of the way. It won't let me, of course. And here we go. So I chose to include the AC within the block itself. You'll see the BT in the bottom right of the AC block. So that means that we've pre-configured it optimally to use with beam tracking microphones. What that actually means is generally we bypass the AGC at this point. I'll go into why later. But the BT is important when you're using Parlé microphones, so I'd always recommend when you're dropping the block in, if you're not using it within the Parlé block, is to select the checkbox that's pre-configured for beam tracking mics. Following that, we can't open this block because it's preset. It's a digital mic gain. So for the TCM1 dependent microphones, we add 12 dB of gain at this point, and for the X series microphones, the table and the ceiling, we had 18 dB of gain. And there is a good reason for that, and that's why it's preset and not configurable. Is we leave the headroom in the microphone itself. So the reason being, if the far end begins to talk at a high level, say through a ceiling speaker, and it clips the input at the microphone, that would cause problems for the AEC algorithm that needs to deal with that far end echo. So we leave plenty of headroom within the microphone itself. And once it's come over the AVB hop digitally, we can use that makeup gain here. And then we have the Uber filters. So these are, they're all the same no matter how many channels that you have here. And generally, they follow a certain sort of paradigm. You take off the very low end of the microphone. The reason being is the larger the mic is, the lower you can track down to. So there is a limit to how tightly you can form beams at low frequencies. So we tend to take off a bit of the bottom end so that we don't get that low frequency build up within the mic. And then you see there are just general, quite broad stroke filters here. If I switch just back to the block, we were on the good setting. If I now go to poor and then go back into custom, you'll see that the block is, the presets are reconfiguring everything for us. So if we go to a poor room, we expect that there will be a lot more room resonances, reverb, noise, things to deal with. So there's a lot more taken out of the mic. And the last setting that the last preset that you chose is what you will see when you go to custom. So I go back to good, you'll see it's reconfigured it for me. Following the filter block, we have an advanced compressor, and what this is doing is it's actually working in reverse, as I say. So if I go quiet, you'll see that the on the meters there that they're pushing the signal level down. So below this threshold here, anything below here is going to be attenuated at the given ratio. So when I go quiet, and then as I begin to speak, more of the signal is allowed through. And what this essentially is a soft noise gate. So when no one is speaking, any ambient noise in the room is just going to push down and just give a nicer experience at the far end. And then we have the gating auto mixer. So how this works is it's, again, you'll see the BT in the bottom right corner. Again, there are some back-end optimizations within it that work particularly well for tracking microphones. It takes a couple of things into consideration. So it takes the overall input level for each microphone and also the overall arrival time, meaning from one mic to another mic, the time it takes for sound to propagate, it's going to be different. And it will make a selection based on what is the best signal level and is arriving first. There are a couple of options in here. You can set open mic limits. Now we've only got 2 mics here. Generally, you'd leave them both active because you don't want it to be either or. It's perfectly fine for different mics to be tracking and for those different mics to be mixed together. But if you have a larger number, you could set an open mic limit. So you say, 3 mics is, I don't want any more than 3 mics to be open at once because I want to keep the general ambience and noise of the room down. Following that, and I mentioned the AGC is disabled in the Beamtracking AEC block, and there's good reason for that. So there's actually automatic gain happening in the microphone itself. Obviously, it's making decisions on an active talker using essentially a real-time algorithm saying, yes, that is someone I want to listen to. And it'll add, as it performs beams, it will add gain as necessary. Now, if you have one process, i.e. the microphone adding gain, and then immediately afterwards you have another process that's doing automatic gain control, the two are going to counteract each other. It's going to say, that level's increasing, I'm going to decrease it. And that's why we disable it in the AGC, in the AEC block, sorry. So we do it afterwards on the direct house. And why we do that is because this signal has been pre-qualified by the auto mixer. So the mic has decided, yes, that's someone I want to listen to. Tracks, adds gain. We go through our processing, and then the gating auto mixer says, yeah, that's someone what you want to pass through to the far end. So now we've qualified that person as a talker that we're interested in. Then we can start to smooth out the level response. And again, the AGC is pre-configured, so this will work in 9 out of 10 installations. And what it's there to do is to smooth the distance between someone speaking who is much louder, projecting to the room, and then someone who is picked up by the same microphone, perhaps on a different lobe at the other side of the table, and who is a much softer spoken talker. And because we're doing discrete automatic gain control, we then need to mix those signals together. And we follow that with the advanced compressor, and that's there to pick up transients, someone walking in the room and slamming the door, putting their books on the table, just to give a more comfortable experience to the far end when you get those transient levels. And then there's a mute control, which can be used. Or if you're using a UC system and you're using USB, then generally the mute could be controlled from here. It actually doesn't matter. And that's it. So that's essentially the whistle-stop tour of the Parlé processing block. In most installations, we can use this block to deploy the system very quickly. You'll see I just threw in a couple of blocks, check my preset, and I can start making test calls and start making decisions on the audio. If you're nearly there and you want to tweak it, then just by all means go into the custom mode. Maybe you want to change the filter slightly depending on how the room sounds. You can go there. As I mentioned before, this is not mandatory. It it is something that we recommend as a really good starting point, and most times it's the finishing point, but it's there just to make things quick, easy, and get good results most of the time. Now, how long have we got left? We've got a couple of minutes, so I'll do this quickly. Somebody asked in the chat about the AI block and how that changes things, and it does and it doesn't change things. So the Parlé processing block was actually designed before we had the AI processing. Now I do have a 040X here, so I can use the AI. Oh, sorry. Now it would be acceptable to add this block here, and that would work. But since we developed the AI noise reduction, we've been working in the development teams, our engineering team have been working on how can we use this new technology and optimize it best for the microphones. And if you went to Infocom or you listened to the presentation for what we're doing in the future, in the very near future for Tessera, you'll see that we have been working on developing this. Now we have AI noise reduction available to us. Rashid mentioned that it will be in software as a new block shortly. Now you can get it already. If you head to Cornerstone, we've got this noise reduction and de-reverberation article, which explains the best ways to use the AI. And here we have a processing library, so you simply just download that, and you've got it's a processing library which we can import into Tessera. So you just go over here on the left, and you can import your processing library. I've already done so. I can get rid of these. So it's over here on the left. I've got 2 mics, so I can just throw that in. And I won't go into too much detail here just because of time, but I'll give you the high level of why this is different. Now you see we're actually adding a slight more amount of gain at the front end. The filter blocks are set this way because we can use the AI to clean up the reverb very, very well. We're just going back to filtering off the very low frequencies to prevent that low frequency buildup. We let almost all of the mic pickup through, and you'll hear that the mics are very full, smooth, and natural, and have really, really good pickup. When you get those tight beams, it sounds really good. We have a gating auto mixer, which has also been optimized slightly to select people quicker. We don't have to be as harsh on mitigating the number of mics, that sort of thing. But the main thing you'll notice is the advanced compressor is missing in front of the auto mixer. The reason being is it was there to keep the noise floor down when people weren't speaking, so that we ended up with a noise-free signal. But the AI noise reduction is actually so powerful that we don't need to do that anymore. So we just pass the microphone through the auto mixer pretty much unimpeded beforehand. And we come to the AI noise reduction. You'll notice this is on the mixed output of the auto mixer, because we only have a single channel and we only need a single channel. If you've not used it before, the AI noise reduction is as simple as, yeah, it's 4 different choices, and this is for incidental noise, so rustling papers, the keyboard tapping, that sort of thing, as well as steady state noise. So it's very good at reducing the common things such as HVAC noise, that kind of thing. And the de-reverberation algorithm is there also to clean up, yes, to deconvolute the impulse of speech within the room. And again, it's 1 of 4 selection. And because we've done that, we noticed that the AI is so good at cleaning up, we can just use 1 automatic gain control after that. And this reacts very quickly, and it works spectacularly well. Because the signal coming into it is so clean, we can add and remove gain as pretty much as we like without decreasing the signal to noise ratio in a way that actually hurts us. So what you end up with is a very clean, very clear signal that is extremely responsive to input signal fluctuations, and you get a very smooth, even output. And again, just a small, the advanced compressor there to take off any transients, and the peak limiter is pretty much always set at that level because that's the clipping point of the DSP digitally. And there are, I think we are on the edge of time. So
yes, yes, we reach exactly 1 hour. I see that you already answered all the questions. There is one last question about the echo cancellation reference that should have as best practice same signal going to the amplifier, and the answer is yes. The best practice is to give to the reference exactly the same signal as much as possible, and then of course we can manage it in case of needs. So I think that with this you covered all the questions. Personally, I thank you for your excellent presentation, and I thank everybody for joining this webinar. So what we can say, just see you to the next one.
Thanks, Jason.
thank you very much.
Thanks, everybody.
Thanks for having me.
See you at the next webinar.
Bye-bye.
Bye.